All right, now let's take a look at this system. We've got 2x plus y is less than 5, and 4x plus 2y is greater than or equal to negative 4. Now, we should be able to tell from both of these that they are linear. They're just going to be lines. And so let's see what that, looks like for us. All right, so I'm going to take this first one right here. I'm going to solve this for y. So y is less than negative 2x plus 5. My slope is negative 2. My y-intercept is 0, 5. Because it says less than, that means that my line is going to be dashed. And it says y is less than, so we're going to shade. We'll shade below. All right, now let's take a look at this next one. If I solve this for y, we get 2y is greater than or equal to negative 4x minus 4. Dividing both sides by 2, we get negative 2x minus 2, so we have a slope of negative 2. A y-intercept of 0, negative 2. Because it says greater than or equal to, we know that line will be solid. We solved for y, and it says y is greater than, so we will shade above. All right, let's put these guys together and see what we have. So starting with the one in blue, y-intercept of 0, 5. Of course, it's got to be open because it's not equal to. Down 2 over 1. And then we're going to dash this guy. Let's go ahead and put a little bit of notation here. It says y is less than, so that means I'm going down from here, where the y coordinates are below that. Now the purple one. Y-intercept is 0, negative 2. Slope is negative 2 over 1. All right. Let's see what we have here. A nice solid line. And this says y is greater than or equal to. So we would shade above for this. Now, because of that, you see where they are both pointing, that's going to be our common region. And it just so happens to be this region that is in between these two lines. These guys are parallel, and they're pointing towards each other, so it's going to be that swath that's right there in the middle. Now, it doesn't have to be that way. Just want to make sure you understand that. Because if it looked a little bit different. So let me just draw this again, just a quick example. If I have this. If I say I'm below this one and above that one. In that case, if I were to ask you where's the common intersection, there's none. They're not going in the same direction. So this would end up being a no solution. So sad, right? But you could have something like this. Let's just pretend these are parallel, okay? If this guy's shading above and this guy's also shading above, where's the intersection? Well, where are they both shading? They'd both be shading in this region that's above that second one. Because if you are over here, you only satisfy one line. But when you're over here, you satisfy both of those. So just be very careful when you're dealing with things that are parallel. Understand that it is possible to have no solution. I mean, you could even have something like this. Suppose I have absolute value like this, and I have a parabola. These guys don't have to intersect. But if I were to ask you, where are you above the absolute value and below the parabola? You would say none. But if I were to ask you, where am I below the absolute value and above the parabola? Then your region would be all of this. So you gotta make sure you pay very close attention to the way that the inequality is pointing so you shade in the correct region. Things are only going to get more fun from here.